Hi everyone, Tina here, and today I'd like to talk about probability tree diagrams involving algebra. You'll need to be familiar with this idea if you're doing the Higher GCSE course. In this video, I'll talk through a couple of examples so you can see how they work. I have made other videos on the basics of probability tree diagrams and also on conditional probability with tree diagrams, so I'd recommend you watch those videos first if you haven't already. So let's start with example 1. There are 4 red counters and X blue counters in a bag. 2 counters are removed from the bag at random. The probability that both the counters taken are blue is 1/3. Work out the value of X. So the question involves probability, which is a clue that we can use a probability tree diagram. I would start by writing down what the options are. So we've got red counters and blue counters, and we're taking 2 counters out of the bag. So we're going to need 2 sets of branches. Now we're told that there are 4 red counters and X blue counters. This is where the algebra comes into it. Means in total, we've got 4 plus X counters in the bag. 2 counters are removed from the bag at random. Let's assume that this is without replacement. In other words, the counters are not being put back into the bag once they've been selected. It then says the probability that both the counters taken are blue is 1/3, which means once we have our tree diagram filled out, the pathway that we're going to be interested in is blue and then blue. But we need to fill in the probabilities on the branches. For the first counter, the probability that it's going to be red is going to be 4 out of 4 plus X, because there are 4 red counters and 4 plus X counters in total. The probability of selecting a blue counter first will be X over 4 plus X for similar reasons. Remember, on probability tree diagrams, the probabilities on any set of branches always add up to 1. So it's always worth checking that that is the case, especially in these algebraic questions. Let's move on to the second counter. So if a red counter has already been taken, the probability of getting another red counter is going to be 3 out of 3 plus X, because now there are 3 red counters to choose from and 3 plus X in total. The probability of selecting a blue counter if a red one was taken first is going to be X over 3 plus X, because there are still X blue counters to choose from. Once again, you can check that these probabilities add up to 1 whole to see if you're going along the right lines. Now, if we've taken a blue counter first, the probability of taking a red counter second is going to be 4 out of 3 plus X, because you have 4 red to choose from still, but the total has been reduced by 1. Similarly, if you want a blue counter second after taking a blue counter first, that will be X minus 1 over 3 plus X. Once again, checking that those 2 probabilities add up to 1. Once we've got the probabilities written down, we can address the next part of the question, which is the probability that both counters taken are blue is 1/3. So what that means is if we times the probabilities on the tree diagram together, so the blue first times the blue second, that's going to be equal to 1/3. At this point, the question becomes more of an algebraic fractions problem, because all we need to do is actually times these algebraic fractions together, like this, and then think about solving for X. Now, when you have 2 fractions that are equal to each other like this, I think the best way to do it is to cross multiply. So that's when you say that 3 times X brackets X minus 1 is going to be equal to 1 times 4 plus X, 3 plus X. So the pink things multiplied together are equal to the orange things multiplied together. That then gets rid of any fractions in the problem, which is great. So now we can just expand as normal, simplify. So I can see that there's X squared involved. So I'm going to bring everything over to the left-hand side and make it equal to 0. I'm going to divide everything by 2, and I'm then going to factorize. You could use the quadratic formula or completing the square if you prefer. Up to you. At this point, we can see there's going to be 2 answers for X. So X is 6 or X is -1. In this context, X is -1 would be invalid because X is the number of blue counters that you have in the bag. So it's got to be X equals 6 for the final answer. Just want to go back and point out a key part of the probabilities again. So at first, for the first counter, the denominator was 4 plus X because that was our total to choose from in the first scenario. However, then the denominator changed to 3 plus X because that is 1 less counter to choose from. Sometimes it's easy to forget to change the denominator as well, so I just wanted to highlight that. Example 2. There are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 4:1. 2 counters are removed at random. The probability that both the counters taken are red is 22 out of 35. Work out how many blue counters are in the bag. So it's similar to the first example, but the way they've given us the information is different. We're given a ratio of red to blue counters as 4:1. Now, because the actual number of counters could be any multiple of 4 and 1, I would write this ratio as 4x to 1x or 4x to x. In total, therefore, we would have 5x counters. I would then draw my tree diagram. Once again, the colours are red and blue. 2 counters are taken, so we need 2 sets. And then we think about the algebra on the probability branches. So for the first counter, the probability that it is red will be 4x out of 5x because there are 4x red counters and 5x in total. For blue, the first counter probability will be x out of 5x because there are x blue counters and total 5x counters. Once again, if you add those probabilities together, you should get one whole. Next, for the second counter, if we've already taken a red one, the probability that the second one will also be red is going to be 4x minus 1 over 5x minus 1. We're reducing both the numerator and denominator by 1 because we've already taken out a red counter. So it goes from 5x to 5x minus 1, and now there are 4x minus 1 red counters to choose from. Probability that it will be blue here is going to be x out of 5x minus 1 because we still haven't taken any of the x blue counters. Probabilities add up to one whole, which is great. On this set of branches, if we've taken a blue counter out first, the probability that we'll then take a red is going to be 4x out of 5x minus 1, and taking a second blue is going to be x minus 1 out of 5x minus 1. Add up to 1, so all good. Now, in the question, it says the probability that both the counters taken are red is 22 out of 35. So the pathway that we're interested in is red in this case. If we look at the probabilities along those branches, that's going to be 4x out of 5x times 4x minus 1 out of 5x minus 1 is equal to 22 out of 35. Again, this is now just an algebraic fractions problem. So we times the tops times the bottoms equal to 22 over 35. We cross multiply because again, we've got 2 fractions equal to each other and this will eliminate the fractions. And when we do that, we get this. So 140x brackets 4x minus 1 from the blue part and 110x brackets 5x minus 1 from the orange part. We then expand and simplify. We bring everything over to the left because it's a quadratic. We can simplify at this point, dividing by 10. We can then factorize and solve for x. So this tells us that either x equals 0 or x equals 3. Checking the context of the question, x equals 0 would be invalid because that would suggest that we had 0 counted in the bag in the first place. So the final answer is x equals 3. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks and see you next time.